In this video, we'll talk about how multiply matrices together. Then we will find all values of k if any satisfy the following equation. Here, this equation, we have three matrices. We will find this k. Since the right hand side equals 0, then we can find this k. Before that, we will solve this question. Here, find AB. This is A matrix and this is B matrix. To multiply two matrices, we have to know the condition of multiplying matrices. Here, this matrix is 2 by 3, 2 rows and 3 columns. So 2 by 3. But this one, it has 3 rows and 2 columns. 3 rows and 2 columns. Since these numbers are equal, then you can find AB. Since we are finding AB, then the size of AB, it will be 2 by 2. So this is how we can decide it if we can find AB or not. Multiplication process, multiply each row from the first matrix. Here, this is the first matrix, and this is the second matrix. So multiplying each row from the first matrix by each column from the second matrix. This is the second matrix. So multiplying each row from the first matrix by each column from the second matrix, considering we will get only one element from each process. We will talk about this one later, but before that, I will illustrate more about the size of matrix. This is called size, order, or dimension. All of them, they have the same meaning. So let's put more example about the size of matrices. So let's go up and put notes. I will put here line. So note. If we have the same thing, two matrices, A and B, one, let's say we have A multiplied by B, and the size of A 4 by 3, and the size of B 3 by 4. Since these are equal, then you can find A multiplied by B. So A multiplied by B, which is this matrix, I put it in bracket. It's mean only one matrix here. We will find as the result of multiplying this matrix by this matrix, and we will get 4 by 4 matrix. 4 by 4 matrix. It's mean 4 row and 4 column. Second example, let's say we have A 1 by 2, and B here we have 2 by 4. So here this number equal to this number, then you can find A multiplied by B. Let's change the color. So AB, the matrix, will be the size 1, 4. 1, 4. So this number here and this number here. So it has 1 row and 4 column. Third example. So here we have A, let's say 2 by 3, and B here 2 by 3. Since these are not equal, then the matrix AB is undefined. So we can't find the matrix A multiplied by B. Example 4, AB, any matrix is A multiplied by B which satisfy this thing, not equal BA. So if you multiply AB and you multiply BA, for example, this 2 by 2, 2 by 2, then these, the same thing, 2 by 2, 2 by 2 matrix are not equal, but sometime AB equal BA, but not always. That's it here to illustrate the size of matrices. Since we have done a lot of sizes here, so the size of AB here, it will be 2 by 2. Now let's solve this question. So question 1, the answer, we will solve this one. A multiplied by B, which is the matrix A, I will take it, multiply by B, which is this one, this matrix has 2 rows and 3 columns, so 2 by 3. And this matrix has 3 rows and 2 columns, so 3 by 2. Since these numbers are equal, then we can find A, B. So we can multiply these matrices. So this equal 2 by 2 matrix, because here this 2 and this 2, so we will get 2 by 2 matrix. 2 by 2 matrix, because here 2 and here 2. Multiply this row by this column, we will get this entries. So minus 2 multiplied by 4, plus 1 multiplied by 3, plus 3 multiplied by 7, which is here minus 2 multiplied by 4, which is negative 8, plus 3, because 1 multiplied by 3, 3. 3 multiplied by 7, which is 21. Add these together, so minus 8 plus, it will be 24. 24 minus 8, which is 16. So this entry equals 16. Let's erase this one. Now we are multiplying this row by this column to find this element here. So minus 2 multiplied by 9, plus 1 multiplied by 6, plus 3 multiplied by negative 2, equal. Now we have to add them together. So minus 2 multiplied by 9, which is minus 18. 6 multiplied by 1, which is 6. 3 multiplied by negative 2, which is negative 6. This one will cancel with this one, so we will get negative 18. So negative 18. Now let's erase this one. Now we will multiply this row by this column to find this entries. So 0 multiplied by 4, plus 5 multiplied by 3, plus 2 multiplied by 7, equal 0 multiplied by 4, which is 0, 5 multiplied by 3, which is 15, 2 multiplied by 7, which is 14. So the answer for this, it will be 29. So this 29. Now let's erase this one. Now we will multiply this row by this column to get this one. So 0 multiplied by 9, plus 5 multiplied by 6, plus 2 multiplied by negative 2 equal 0 multiplied by 9, which is 0, plus 5 multiplied by 6, which is 30, 2 multiplied by negative 2, which is negative 4, 30 minus 4, which is 26. So this one, it will be 26. Let's erase this one. Now we have solved question 1. So let's solve the question 2. Question 2. To multiply these matrices, you can find them by multiplying these two, then the result of these two, multiply by this one. Or you can find them by multiplying these two matrices first, then the result of here, you will keep it, then multiply this one by the result of this one from the left. So you have two ways. I will choose the first one. So I will multiply this one by this one. Let's copy it. Here the size of this matrix 1 by 3 and the size of this matrix 3 by 3. Since these two numbers are equal, then you can find these multiplication. So the result of matrix 1 by 3 matrix. So 1, I will put it larger, 1 by 3. So this is the first column, this is the second column, this is the third column. So we have here 3 columns. Now let's multiply this row by this column and we will get this entries. So k multiplied by 1 plus 1 multiplied by 1 plus 1 multiplied by 0, which is k multiplied by 1, which is k, plus 1 plus 0, which is k plus 1. Here I will write k plus 1. Now let's erase this thing. Now let's multiply this row by this column to find this entries. So k multiplied by 1 plus 1 multiplied by 0 plus 1 multiplied by 2. K multiplied by 1, which is k, plus 0, because 1 multiplied by 0, 0, plus 1 multiplied by 2, which is 2. Then we will get k plus 2. So here, k plus 2. I hope we have space to write this entries here. So now we will erase this thing. This row multiplied by this column, we will get this entries. So k multiplied by 0 plus 1 multiplied by 2 plus 1 multiplied by negative 3. Now here k multiplied by 0, which is 0, 1 multiplied by 2, which is 2, 1 multiplied by negative 3, which is negative 3. Then we will have the result as minus 1, because 2 minus 3, which is minus 1. So here minus 1. Now let's erase this computation. Now we have find this multiplication, which is this one. Now we will multiply the whole thing. So I will copy this result and then I will copy this one. So now we have the left hand side of the equation of this one, which is this one multiplying by this one. Now we are computing the left hand side, which is the result of this one, which is here, and this one is here. So after compute these multiplication, we will compare it with this 0. This 0, it's a matrix, not only one number. It's represent 0 matrices. So let's do it now here. Multiply this row by this column. So let's do it. Let's go down a little bit. So this one multiply by this one. K plus 1 multiply by k plus k plus 2 multiply by 1 plus negative 1 multiply by 1 equal multiplying these together. So k multiplied by k, which is k square, 1 multiplied by k, which is k multiplied by 1, which is k, 2 multiplied by 1, which is 2, negative 1 multiplied by 1, which is negative 1, equal. Here we have only k square, so k square, k plus k, which is 2k, 2 minus 1, which is 1. So the left-hand side, which is k squared plus 2k plus 1. Now we have to compare it with this 0. So here, the answer of multiplying these two things, which is matrix, which is k squared plus 2k plus 1. To illustrate more about this, here we have only 1 by 1 matrix. Why here we have 1 by 1 matrix? Of course, when we are multiplying these matrices, we will get the result, which is this one. Here, this matrix has 3 rows and 1 column, so 3 by 1. Since these numbers are equal, then this number with this number represent the result matrix, which is here 1 by 1 matrix. Here 1 by 1 matrix. Here we have only one number. For example, if k equal to 0, 0 plus 1, which is 1, here we have a matrix which has entries 1. If we substitute k equal to 1, then 1 plus 2 plus 1, which is 4, we have only one element, which is 4. Here we have to compare this matrix with a 0 matrix. Of course, if we want to put a 0 matrix, we have to put it as 1 by 1 matrix. And we will see how can we solve it now. Now we have to compare this k square plus 2k plus 1 with a matrix which is 0. So hence k square 2k plus 1 equal to 0. Then from here, by factoring this equation, we will have k and k and close this bracket equal to 0. Since this one is positive, then both of them we will have positive or negative. So since this one is positive, so it will be here positive and here positive. And of course here we can factoring this equation by here 1 and here 1. So 1, 1. As you can see here, this one it's equal to k, this one it's equal to k. Add them together, we will get 2k. So the solution of this equation, which is k equal negative 1, negative 1, which is the root of this equation. So finally, we find k. We can write k equal only negative 1 because we are only finding the value of k. So here the k is negative 1. You can confirming your solution by substitute k equal negative 1 in the matrices and you will get 0. That's it. Hopefully you find this video is interesting and motivating you to solve more questions. See you in the next video.